Hi everyone, in this video we would be designing the customer issue resolution system which was recently asked in PhonePe's machine coding round. So let's get started. So this was the question which was asked in the PhonePe's machine coding round. If you want to read this, then you can pause the video and read this. However, I'll try to explain this in my words. So first of all, if you don't know what is PhonePe, it is an application which allows you to send the money to any recipient. It can be your family member, friends, or any shop owners or anyone, right? But the thing over here is, let's say you are trying to transfer the money to any recipient and your money gets debited, but transaction is failed. That is, the recipient has not received the money. So in that case, the only thing that you can do is complain about this to the PhonePe, right? And in order to complain this to the PhonePe should be having the customer issue resolution system, isn't it? So that is the system we have to build in this particular machine coding round. All right. So over here, you would be creating an issue in their system and one of the agent will be working on that issue until it is resolved, right? So this is the system we have to build. Now let's check out the requirements. So these are the 7 functions which we need to implement. And PhonePe is also saying that they understand that you may not be able to complete all the functions. So in that case, they have also given the priority, like you should start solving the functions from top to bottom. This has higher marks and this has least marks. All right. So now let's see all the functions one by one. The first function is create issue. So this function will basically be called by customers in order to create an issue. Now, while creating that issue, the customer would be providing certain parameters, right? So these are those parameters. The first one is the transaction ID which got failed. Second one is the issue type. Okay. So in the question, they have mentioned that there are 4 types of issue. First is payment related. Second, mutual fund related. Then gold related. And finally, we have insurance related issue. All right. So while creating the issue, the customer has to select one of the issue type. And customer should also provide the email ID, description and subject related to that issue. All right. And once this issue is created, this issue should be assigned to some agent, right? So for that, we need some agent in our system. So in order to add the agent, we have this function called as add agent. So in order to add the agent, we have to pass the name and email of that agent and the expertise of that agent. One agent will obviously not be capable to solve each and every issue in this world, right? So that's the reason why each and every agent should have specific expertise. For example, agent 1 can only solve gold related and mutual fund related issue, whereas agent 2 can only solve payment related issue, and so on and so forth, right? So this is how the add agent function would work. Now, once the issue is created and we have the agents in our system, we have to assign that issue to some or the other agents, right? So for that, we have this function called as assign issue. So in order to implement this function, we have to check 2 things. The first is the agent should be capable in solving that issue type. And second is that agent should be available, right? And let's say if there are no agents who are available, so in that case, I have to add this particular issue into the wait list of any agent who is capable in solving that issue type. All right, we'll see this in the code section. And the fourth function is getIssue by the filter. Now the cool part over here is this filter can be anything. We can pass anything which we want. And based on that, we will get the output. We'll get the list of issues. All right. For example, if I want to find all the issues based on issue type, I'll just pass the issue type over here and I'll get all the issues which belongs to that issue type. These are the 2 functions which will be called by the agents. So let's say if there is an update on a specific issue, then agent will be calling this update issue function. And if that issue is successfully resolved, then agent would be calling this resolve issue function, right? Then finally, we have this function called as view agent's work history. So when we call this particular function, we will be able to see the history of all the agents. For example, agent 1 has worked on 3 issues, agent 2 has worked on 5 issues, and we should also be able to see what are those issues, right? So these are the 7 functions which were required in order to clear the round. And the candidates were also given the test cases like this. So we have to demonstrate this test cases to the interviewer after we code entire low level design for this round, right? So we have to call these functions and the output should match. Okay. So I'll be explaining this stuff directly into the code section. But before that, let's see the class diagram. Although the class diagram is not needed in the machine coding round, but I have still created this so that we can visualize the entire flow of our application, right? So what I've done is, firstly, I've created the models which we can observe from the requirements. So the two models are agent and issue. So agent basically has these attributes, right? So whenever we call that add agent function, we have to pass name, email, and expertise. That's why these attributes would be present into the agent class. So apart from that, I have also added 3 more attributes. The first one is assigned issue ID. So this agent would be working on certain issue, right? So that issue's ID would be present over here in this variable. Further, we should be able to see the history of that agent, right? So that's the reason why I have the list of issue ID, which will help me to view the entire history of this agent. And agent will also have the wait list. So let's say this agent is busy and this agent has the expertise in solving a particular issue. So that issue can be assigned to this agent. That is, it can be added into the wait list if this agent is currently busy. All right. So these were the attributes in agent class. Now coming to the issue, again, while creating the issue, we were passing certain attributes like transaction ID, issue type, subject, description, and email. So that's the reason why I've added them into this issue class. Now, apart from that, I've also added 3 more attributes. The first one is the status of that issue. So issue can be in this 4 states. So whenever any customer creates this issue, at that time it will be in the open state, right? And let's say agent has started working on this issue. So in that case, it will be in the in progress state. And when this issue is resolved, at that time it will go into the resolved state. And also it has this waiting state, because let's say none of the agent are available. So in that case, this issue would be added to the wait list of a particular agent. So in that case, it would be in waiting state, right? So if you have seen my other videos, you might be knowing that in this repository layer, we would be having this in-memory database, which is this HashMap. This database would be storing all the agents, right? And in order to perform the CRUD operations on that, we have these functions called as save, get by ID, and get all. And same thing is copied into this issue repository. Okay. Now we also have the service layer. So in the service layer, we have total 3 classes. The first one is the issue service. This service will have these 4 CRUD functions: create issue, get issue by a specific filter, update the issue, and resolve the issue. Then we have this agent service, which has add agent function and view agents work history function. And the last one is the assignment service. So over here, the function we have is the assign issue. So this function will be responsible for assigning this issue to one of the agent. Okay. So this assignment service will interact with the assignment strategy. So selection of a particular agent will be dependent on this strategy. So by default, we would be using this default assignment strategy, because in the question it was specified that. Okay. This function will basically go through each and every agent, and it will check 2 things: whether the agent is available and that agent has expertise. If both of these conditions are fulfilled, then we'll be assigning this issue to the agent, which is written from this function, right? And for this particular component, I'm using the strategy design pattern, because in future we can have different assignment strategies, different types of algorithms for assignment, right? So that's the reason why I am using strategy design pattern over here. Now, in case if none of the agents are available, that is, let's say this function returns null. So in that case, I will assign this issue, or I will add this issue into the waitlist of any agent who has the expertise. All right. So we have seen all the entities and the classes present in the class diagram. So I hope you understood this entire class diagram. Now let's see the code. So this is the main class. Over here, I've created the repositories and services. Then after that, using the issue service, I've created the issues. So total, we have created 3 issues. The first and the third issue are payment related, and the second issue is the mutual fund related. And first issue is created by user 1, whereas remaining issues are created by user 2, right? Then obviously we should be having some agents into the database, right? So for that, I have added 2 agents, agent 1 and agent 2. Now, point to remember over here is there are 3 issues and there are only 2 agents. So it means that one of the issue will be going into the wait list of one of this agent, right? Now after this, I am calling this getIssue function, and the filter over here is the email. It means that I want to get list of issues created by user 2. So if you see, the issue number 2 and issue number 3 are the issues created by user 2, right? Then I have again called this getIssue function, but this time instead of searching by the email, I'm trying to search by the issue type. So what this will give me is list of issues which are payment related. Okay. Then after that, the agent who was assigned this issue has started working on that issue. So he has basically turned the status of that issue from open to in progress, right? Now let's say after this, that agent resolves that issue. So in that case, this function would be called, okay? And the agent will also update the resolution. And at the end, we are checking out the history of all the agents in our system. Now let's run the code. So firstly, we have created the issues and agents. Now after that, as we discussed, I will be getting the list of issues based on the email ID. So we will get issue number 2 and issue number 3. And we will also try to get the issues based on the issue type. So issue number 1 and issue number 3 would be returned because they are payment related. And further, the agent has started working on issue 3, right? So the status of that issue would be updated from open to in progress. So this is the issue 3, as you can see the ID over here. Then that agent has also resolved that issue. So this message is printed. And finally, we are also seeing the work history of all the agents. So work history of agent number 1 is empty because that agent has not resolved any issue so far. And this agent has resolved this issue, that is issue number 3, right? So I hope you understood this output. Now let's check out the code. So I've created various packages like enums, models, repositories, service, and strategy. Let's look at each of these classes one by one. So first, let's see the enums. So we have 2 types of enums in our system. The first one is the issue type. So for this, I've just copy pasted all the types of issues which were mentioned in the question. And the second one is the issue status. And I've also explained this different statuses in the class diagram part. Okay. Now let's check out the models. So we have 2 models in our system. The first one is the agent and the second one is issue. Now for both of these models, I've explained the attributes in the class diagram part. Like what are those attributes and why are we using those attributes? So I think there is no need to explain them again. Further, we have this repository layer. So over here, I've created agent repository and issue repository. So both of this repository would be having this in-memory database. So in the issue repository, I would be having this issue database. and we would be having this CRUD operations which would be performed on that issue database. And the same thing would be copy pasted in the agent repository. So as you can see, there is literally no change apart from the object, like agent would just become issue. Okay. So now let's check out the service layer. So in the service layer, we have this three functions or three classes basically. So the first one is the agent service. In the agent service, we have add agent and view agents work history function. So in the add agent function, we would be first creating the object of the agent based on the parameters passed over here. And after that, we would be saving that agent into the agent database with the help of the save functions present in the agent repository, right? Now the second function was to view the agent's work history. So for that, we are iterating through all the agents. Now before iterating through the agents, I am fetching all the agents which are present in the agent database, right? So this function will give me all the agents, and then I am iterating through them and just printing out this stuff. Okay, so this get history will give me the history of that particular agent. Then we have this issue service. Over here we have this four functions called as create issue, get issue, update issue, and resolve issue. So let's see the create issue first. So in order to create the issue, we have to first create the issue object based on the parameters which are passed over here, and then save that into the in-memory issue database with the help of this CRUD operation. And then we'll just return this issue which we have created. Second, we have this get issue function. So this function is responsible for getting the list of issue based on the filter which is provided by the agent. So let's say the agent wants to search the issues of this particular email address. So in that case, the key would be the email and the value would be this particular actual email string, right? So for that, what I'm doing is I'm first fetching all the issues from the issues database, and then I'm filtering those issues one by one. So for that, I'm checking whether the key is email or type or status. Now let's assume that this filter was this particular stuff. So in that case, we have to check whether the key is equals to email or not. And indeed it would be the email, right? And then we'll compare whether the customer's email address is equals to the email address provided over here. If it is not same, then we'll return false, indicating that this issue should not be added into the final list. And if it was true, it means that we would be adding that issue into the final list, right? So this is what the get issue function would look like. Then we have this update issue function. So over here, we are first fetching the issue from the in-memory issue database with the help of this particular ID. And then we are just updating the status and the resolution, which is provided over here. Now coming to the resolve issue function, this function also has the similar logic. Only change is the status would be automatically resolved, right? We don't need to pass any status over here. And one more part which is added over here is we are fetching the agent from the agent database. Why? Because once the issue is resolved, that issue should be added into the agent's history, right? So for that, we are first fetching the agent and then adding this particular issue ID into the history of that agent. And I'm also setting this particular variable of that agent to null, indicating that now agent is not working on any issue. Indirectly, I'm saying that agent is available. Okay. So these were the functions present in the issue service. Now coming to the assignment service, which has this function called as assign issue. This function will basically assign this issue to one of the agent, right? So firstly, I'm fetching the issue based on the issue ID, and I am also fetching all the agents available in our in-memory database. and I'm passing the agents and the issue to this strategy. Okay, so by default we would be using the default assignment strategy. So this particular strategy will return me the agent to whom I have to assign this issue. Okay, so let's first see the strategy. So for the strategy design pattern, we have this strategy interface, and this interface has one function called as assign. This function basically goes through each and every agent present, and it will try to check whether we can assign this issue to one of the agent or not. And if the answer is yes, then in that case I am returning that agent. Okay, so now let's check out the default implementation of this class. So in this default assignment strategy, I am first iterating through all the agents passed in this list and checking whether that agent is available or not. And if that agent is available, in that case, I'm checking whether that agent has the expertise to solve that issue or not. And if both of these conditions are true, then in that case, I am returning that agent, indicating that we should be assigning this issue to this agent. Okay. Coming back to the assignment service, so this strategy would be giving me the agent to whom we have to assign this issue. Now, if that agent is not null, okay, in that case, I am just going to assign that issue. And if that agent was null, in that case, I am again iterating through all the agents and just checking the expertise. Okay. This time I'm not checking the availability because all of them are busy, right? So I'm just checking the expertise, and if any agent fulfills the expertise, in that case, I am adding this particular issue into the wait list of that agent, and the status of that issue would become waiting status. All right. So this was the assign service class. So with this, we have seen all the classes present in our system. So I hope you have understood the entire code. If you did, then please like the video and share this with your friends. Thanks for watching.